In this video series, we're going to be examining Pascal's triangle and the binomial theorem. In this particular video, we're going to introduce Pascal's triangle and show how it can be used to expand the power of a binomial. So just a little bit of history. Pascal's triangle was given credit for discovery by Blaise Pascal. He published it and showed a lot of properties of it. However, it was first discovered by the Chinese in the 13th century for it. And it's a pattern of numbers that exists that we use and creates a triangle for it. So if we take a look at how Pascal's triangle works, each row begins and ends with a 1. And so you can see the triangle down here. Each row begins and ends with a 1. The triangle is symmetrical around a vertical line in the middle. And what that means is if I were to draw a vertical line, you notice if I go here, around the middle, there's a 1 and 3 to the left, and then 3 and 1. So it's symmetrical around the middle vertically for the pattern. And the way the numbers are found, the way the numbers are created in Pascal's triangle is by adding the two values diagonally above it. So in order to get this 2, we took 1 plus 1, and that formed the 2. In order to get this 3, we took 1 and 2 and add them together. So if I jump down here, this 15 was discovered by taking the 10 and the 5. The 10 was discovered by the 6 and the 4. The 6 was discovered by the 3 and the 3. And so that's how each row is created. You start with a 1, and then you add these two to get the 3. You add 2 and 1 to get this 3, and so on. So that's how all the values are found. Now this triangle continues on forever, and it has many properties beyond binomial expansion. I encourage you to go online and do some research on Pascal's triangle and all the mathematical concepts hidden inside of it. Now what we're going to use is we're going to try and take Pascal's triangle and create our binomial expansions, which we can see over here to the right. So to do this, what we need to look at is how the Pascal's triangle relates to the powers of a binomial. So if I take a look, the first row, which is just 1, represents a binomial to the 0 power. The second row, which is 1 and 1, represents a binomial to the first power. And we notice, and we can see the numbers in the row represent the coefficients of the binomial expansion. So if I have a plus b squared, I'm going to go here. I have the numbers 1, 2, 1. And so those become the coefficients of my binomial expansion, 1, 2, 1. And I'm going to explain a little bit later how we get the powers. And so if I look here, this would be to the third power, 1, 3, 3, 1. And those are my coefficients to the third power, 1, 3, 3, 1. Same thing with fourth power. So now I'll explain, we can use the fourth power to kind of help us with our exponents. The coefficients are 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1. And so if I want to create now the variables and the exponents after taking a look at those coefficients, well, if it's the fourth power, you know you're going to start with the fourth power. It's the highest power you have. And so we'll just focus on A. A is the fourth power for the first term. Then it's the third power. Then it's the second power. Then the first power. And then it's no longer there, which would really be the 0 power. So what we can see, 4, 3, 2, 1, 0, for the exponent for A, we notice the powers decrease for A with each term. So now let's focus on B. There is no B here. So that's like B to the 0 power. Then we have b to the first, we have b squared, b cubed, and b to the fourth. So we have 0, 1, 2, 3, 4. And so the powers of b increase with each term. So the powers of a decrease while b increase. I like to make a note, we don't write coefficients of 1. And so this is really what the binomial expansion looks like without the coefficients of 1. Now this is just an introduction. You have yet to actually apply this binomial expansion, so don't get too caught up on, well, I don't quite understand that yet. You'll look at a couple of examples in the next video to help out with it.